Hello and welcome back for the video for lesson 7.4. We are still working with quadratic equations. This lesson is just all about, there's expressions or equations within equations sometimes. And so this is an extension of what we've already learned. So it says, for example, we have the expression of x plus 4 squared minus x plus 4 minus 6 equals 0. So if we could think of it like this, we've got a something squared minus that same something minus 6. If we were to let x plus 4 be represented by u, then we can solve for x or u in that case by substituting in u equals x plus 4. So let's look at this u squared minus u minus 6 equals 0. And we'll think of it as this is just our original equation. In this case, we could factor this into u minus 3 times u plus 2 equals 0. So if that's the case, that means we can use our zero factor theorem, which says that u minus 3 can equal 0, or u plus 2 can equal 0. And so that means we can put x plus 4 in for u and solve for x. So x could equal a -1, or over here, if we put x plus 4 in, we get x plus 6 equals 0, and subtracting 6 on both sides, we get x equals a -6. So it's nice sometimes when we can substitute u or another letter for the expression that's inside the parentheses. And that way it just makes solving easier because we could factor quickly and then go back in and substitute our expression back in for u. So let's look at example 2. Example 2, it looks like we have this x minus 5 that we could let u equal. So
it's critical in securing our.
We have, sorry about that, u equals x minus 5. And so this is really 3u squared minus 14u minus 5 equals 0. And now we have a quadratic that we can just try to factor or use the quadratic formula to solve for. So I'm thinking if we do use factoring, if we do u minus 5 here, we would get a -15 plus 1 is a -14 in the middle, and then that still multiplies to make the -5 on the end. And so then we can set 3u plus 1 equal to 0. And so 3u equals a -1, and u equals a -1/3. But u actually equals x plus 5. So we could have even done it in here in this step. So we don't have to deal with the fractions. So 3 times x minus 5 plus 1 equals 0. So 3x minus 15 plus 1 equals 0. So 3x minus 14 equals 0. So 3x equals 14. So x equals 14/3. That's that one. So not quite 5. And then over here, we have u minus 5 equals 0. And if we put x minus 5 back in for u, we have x minus 10 equals 0. So x could equal 10. Those are our two solutions. So let's look at example 3. Example 3. First, I'm going to bring my 30 back to the other side. So I have x to the 4th minus 11x squared plus 30 equals 0. So I'm going to let u equal x squared. So I have u squared minus 11u plus 30 equals 0. And we need two numbers factors that multiply to make 30, but when you add them, they make a negative 11. So I believe a u minus 5 and a u minus 6 works. And then we can put x squared back in for u. So x squared minus 5 equals 0, or x squared minus 6 equals 0. And then x squared equals 5, or x squared equals 6. And then taking the square root, we've got plus or minus the square root of 5, or plus or minus the square root of 6 are the four solutions that work. Example 4 says, for example, we have x minus 6 times the square root of x plus 8 equals 0. This one's a little bit trickier because it's not really something that looks bigger and we're kind of narrowing it down. We have to kind of build it up. So we can think of this as like a u squared minus 6u plus 8. So if we do that, we have to figure out what u would be so that this comes out to be just x. So if u equals x to the 1/2, then we have x to the 1/2 squared equals x, which is what we want, because we want it to match right there. So we're going to let u be x to the 1/2. And so we have u squared minus 6u plus 8 equals 0. And this factors beautifully into u minus 4 and u minus 2. And so u minus 4 equals 0. So u equals 4. But u actually equals the square root of x, because that's x to the 1/2. So if we square both sides, x must be 16. And then over here, we have u minus 2 equals 0, u equals 2. And again, x, the square root of x equals 2. And if we square both sides, x must be 4. So let's do something similar here for example 5. Again, we have the square root of x, so we're going to let u be x to the 1/2 or square root of x. So we have u squared minus 3u minus 10 equals 0. And that factors into u minus 5 times u plus 2 equals 0. So u minus 5 equals 0, so u equals 5. So the square root of x equals 5. And if we square both sides, then x must be 25. And then we have u plus 2 equals 0. U equals a negative 2. So when does the square root of x equal a negative 2? It would have to be an imaginary. So that one won't that one's a possibility of not working. Let's just check that. And go to Desmos just to check it out. So let's put in I equals X minus 3 square root of X minus 10. And I'm going to zoom out so we can see this. So you can see that, yes, it only crosses at this positive 25. So that is our only solution. So that's the only solution. And that's the end of lesson 7.4. So catch me back for 7.5.